So thank you very much, Valentina, for inviting me to speak at Big Data Week. So my name's Jim Anning. I'm head of data and analytics at an outfit called British Gas Connected Homes. Most of my day job involves those three things. So I look after data science, data engineering, and data operations across all of Connected Homes products. So we'll start off with some context, and then I'll talk about the meat around Internet of Things, data, and value. Right. So British Gas. So British Gas used to be a little tiny startup in about 1812. So historically, so the Napoleonic Wars were going on. I think America had declared war on us again. So a very kind of different time historically. And so British Gas have obviously grown. They're the UK's largest energy utility, so around about 11 million customers. There's also a field service arm, so 10,000 engineers driving around in vans fixing stuff. Makes it Europe's largest mobile workforce, which is interesting. And so how come, I mean, if I'd stood here 3 years ago and said that in 2015, you'd be able to walk into an Apple store and buy a product that had a British Gas brand on it, you'd have probably looked at me kind of a bit like that and thought I was a bit mad, and you might have been justified. However, that's exactly what we've done. So the Hive thermostat, which is entirely built, designed, owned by Connected Homes, which is an offshoot of British Gas. So you can walk into an Apple store today and buy that beautiful thermostat. And if 3 years ago, I think if someone had said I'd stood on a stage saying that the thermostat was beautiful, I'd have seriously questioned myself. So how have we done that? So around about 3 years ago, some very, I think, foresighted people in British Gas realised that there was something, they didn't know what, but something around the Internet of Things and energy, so the intersection between those two things. And so they set up an entirely separate organisation, not based in British Gas offices, with about a 70-30 split at the time of people who came out of British Gas, so 30% out of British Gas, and about 70% of us came in from various startups and other companies. And so off you go and innovate in this space. And so since then, I joined 2.5 years ago. There were about 50 of us in a basement near Soho. There are now 370 people in the company. So we've grown massively over the last 3 years, and we've done quite a few things. So we do three things. The first of them, which is the one that many people will have heard of because of the adverts, which, depending on whether you're marketing or not, are kind of great or really annoying. But Hive. So Hive allows you to control your heating from your phone. So we have 250,000 customers in the UK today with a connected thermostat, which bizarrely makes British Gas the largest consumer Internet of Things play in the UK right now, which is not where you would have thought it would have gone. Secondly, we do a product called My Energy. So My Energy takes data from gas and electricity smart meters, and then helps people understand how they're using energy and builds a better relationship with British Gas's customers based on being very, very transparent with them about how they use energy. And then the last thing we're working on is something called Smart Boiler. So a central heating boiler contains loads of sensors. You wouldn't believe how much is going on inside one of those things. And so we're developing solutions which take the data out of those boilers and pass them back over the internet. And then eventually our aim is to do the data science, which will allow us to do proactive preventative maintenance. And when you think about an organization that has 10,000 engineers driving around in vans, being able to know what's going to break when and how it's going to break is massively valuable, both in terms of a customer experience and in terms of the costs of having 10,000 people driving around the country. So I think there are two threads that I see running through Connected Homes. One of them is innovation. That brave decision, I think, at British Gas to create something separate and to give it the space to innovate is the reason that we have been successful. we do a lot of experiments. We learn a lot. We consciously fail all the time in small ways by doing experiments. Every time you do an experiment, you don't know whether you're going to be right, so you have to experiment. That means you have to create a culture where it's okay to fail, and they've done a remarkable job of that, given that its history is out of a 200-year-old utility. And the other, and I think picking up on Johanna's point earlier, is the engineering. And I prefer the second definition on here, the action of working artfully to bring something about. And I think that runs through the organisation as well. So that's the context. So 200-year-old utility, spawns, lean startup. Lean startup does a whole bunch of experimentation and kind of mindful, conscious success and failure ends up doing three things which you would never have believed an organisation like British Gas could do. So Internet of Things. So 2008 was a really important year in this story because 2008 was the year when the number of things connected to the internet exceeded the number of human beings on the planet, which is that's amazing, and that happened back in 2008. And we've been on this journey. So we've connected computers to the internet. We then had a bit of a revolution when we went mobile, and everyone sort of carries their connection around in their pocket. And then we talk about this Internet of Things thing, and people start about connected fridges, connected washing machines, and everyone goes, and maybe quite rightly, because I think when we think about the Internet of Things, you've got to not think about kind of big things. You've got to think about small things, so sensors and actuators. And what's really driving this is that the cost of connecting tiny little things, so a sensor that measures temperature or humidity or flow or consumption, the cost of connecting that sensor up to the internet is just plummeting. And that's what's making it a lot easier to connect lots of things. There are still massive challenges, so it's actually very, very easy to connect something to the internet now. If you look at the number of Kickstarters doing it, primary schools, whatever, it's very easy now to connect stuff to the internet. It's a very hard problem to scale that up to millions and millions of devices. So connecting sensors, but also connecting actuators. So things that do something, like a motor or a valve, or a light, or so the ability to collect small amounts of data and the ability to make small changes to the world. I think that's the way to think about the Internet of Things. So there are all kinds of predictions around, and everyone's predicting everything for 2020 at the moment. And depending on who you believe in terms of connected things by 2020, the estimates range from somewhere around 20 billion to somewhere about 100 billion. And that's a massive, massive number. So let's take 50 billion as being the kind of median point of the estimates. 50 billion is a massive, massive number. And the only way I can kind of comprehend this is to think about the galaxy that we live in, the Milky Way. Astronomers think that there are about 300 billion stars in that. So that means in terms of connected devices by 2020, if the pundits are right, it kind of looks like that. Quite a large proportion of the galaxy. It says you are here there. That's a lie. I made that up because it kind of amused me. If you look at Google Trends and type in Internet of Things, you see this curve. So Google Trends just tells you how people are sort of talking about or searching for a particular theme, and this is the Internet of Things. So back in 2008, no one really talking about it. We've had this huge kind of increase in people talking about the Internet of Things. I've put connected homes born at about the knee in that curve. I'm not claiming any causality whatsoever. It's purely correlation. But you can see that the Internet of Things is a thing. That's the 2015 Gartner hype cycle. I've pulled out the salient things on there. So Internet of Things right at the top of that. I haven't been to a conference for months where the Internet of Things hasn't been mentioned in almost every talk. I suspect if you go to an HR conference or a finance conference, they're probably talking about the Internet of Things as well. And the connected home coming up the cycle, and Internet of Things platforms also. So that's the Internet of Things. The eagle-eyed of you would have spotted that on the 2015 Gartner hype cycle, there is no mention of the big data word, which is interesting. I think we've been talking about big data for a long, long time, and I kind of feel like that now. what is big data? I think there's been this sense that either you have big data or you don't have big data. I don't think that's the way to think about it. I think big data is really, really relative. And I think big data, you have big data at the point when you need to make some different technology decisions in terms of how you handle that volume. And I don't really care whether that means that you've dealt with things in an Excel spreadsheet and now you use a database, or you've been dealing with stuff in relational world and now you've gone NoSQL, or you're going somewhere beyond that. And I think that, I probably have access to more data than some of you in the room. I suspect that many of you in the room have access to more data than me. So it is a completely relative thing. And I think the important thing, like Jana said, it's not necessarily the data, it's what you do with it, which is the important thing. So having stood here and said it doesn't matter what size data is you've got, this is how big my data is. So Hive generates around about 500,000 data points per customer per year. So we measure things like temperature inside the home, which is a very interesting thing to measure if you're interested in energy and heating. We have two products in that My Energy space. So this is the helping people understand their energy usage. One of them, where we have around about 700,000 customers who are on smart meters that deliver us an electricity or a gas reading every 30 minutes. So that's 17,500 data points per customer per year. We're doing some experimenting where we've got about 2,000 people right now on a product which gives us an electricity reading every 10 seconds. And at that point, you're generating just over 3 million data points per customer per year. And then smart boilers, the connecting all of the sensors in the boilers. Who knew how much stuff happens inside a boiler? But one of those generates about 4.4 million events per year, which is amazing, seeing as most of us just see that as a box which sits in a cupboard somewhere. So, if the video worked, there was going to be a really, really good. Oh, yeah, there is. Okay, brilliant. So this is some data. So this is London. Those dots are every single electricity smart meter that British Gas has in London, and the brightness just shows you the consumption as the day goes by. So 6 o'clock, people start waking up. At 9 o'clock, you get this kind of sort of dip in the peak, and then during the day you have this it kind of looks random pattern of stuff happening. Obviously that's not random, that's people's choices about how they use energy and how they live their lives. 4 o'clock you start getting the home from school. 6 o'clock you get this evening peak which shoots up. And then the next bit is just the most disappointing thing, because when we did this, I was hoping to prove that London was a city that never sleeps. Unfortunately, that's not true. About 11 o'clock, it does. Everyone goes to bed, it dies down. If you want to go to a good party tonight, it's that bright dot just up there. So that's the data that we get currently for 700,000 customers. By 2020, the government has said that everyone will have a smart meter. Whether that happens or not, I don't know. But potentially, we're looking at 11 million or so customers giving us that kind of data by 2020. So this is kind of more interesting data. So this is data from Saturday, from 32 of our customers who are trialing our My Energy Live product. So this is the product that gives us an electricity reading every 10 seconds. So each line of those is a customer. That's 24 hours running across from left to right. And then what we've plotted here is the every 10 seconds what the consumption is. If you're going to be nerdy about it, that's actually the logarithm of the consumption, so that because that just kind of pulls out what's happening overnight more. And you can kind of see lots of different stuff in that data set. So if I just pull a couple of interesting things out. So here, overnight, this is a very, very regular pattern. This is a fridge. The fridges go on and they go off. They cool things to a certain temperature. The thermostat kicks in, and they switch off, and then they switch on again. And you get this very, very regular pattern from a fridge. Over here, there's a pattern of an oven. So ovens heat up, and then once they've reached temperature, they sit there and they do that same sort of thermostat thing. So they switch on and they switch off to maintain the temperature. Over here is the signature of a washing machine. So again, a heating cycle first of heating the water, and then lots of spinny stuff after that. That's a technical term, by the way. But here's the problem. So it's really easy to pick out these things. But the problem is most of the data is really, really noisy. Yeah, it's not just a fridge or a washing machine. It's a whole bunch of other stuff happening at the same time. So the data is really, really messy. So how do we extract some value from that? Well, the value proposition is easy, right? So it used to be that your utility would send you a piece of paper every 3 months or so. The number on it was generated by a human being visiting your house and reading a number off a meter. Now we can do that stuff in real time on your phone, which is cool. And also we start to give people the ability to not only understand what they're using, but to control it as well through products like Hive. So a couple of things. So on the innovation side, data science is obviously really, really important competency to have in your organization for this kind of stuff. That's my favorite definition of a data scientist. So someone who knows more about statistics than a software guy, and more about software engineering than a statistician. And this is my definition of a good data scientist. Kind of magical unicorn kind of guy. And you know, they are hard to find. Luckily, I've managed to gather a good set of data scientists. If you want to talk about that, my head of data science, Miroslav, is sat there and will be hanging around today. And feel free to badger him. Don't nick any of them. So data scientists. So the fridge example earlier. One of the things that this is how we pick out the pattern of a fridge from a large data set. So we are able to do a whole load of clustering on data. Each of these points is a kind of energy event. The ones in blue have been clustered into the area that we expect to see a fridge. I like that, A, because it's a very cool way of extracting some value, some goodness from that data. Secondly, in my head, it looks like that, which kind of pleases me quite a lot. The second of the two things is data engineering. So that's what our technology stack looks like today in Connected Homes. It's pretty much all open source. The largely Cassandra and Spark at the moment, which are two very, very interesting technologies. The thing that we're getting really interested though is Kafka. So one of the things that we see with all of the energy use cases is the really important thing for people is to do it in real time. You know, right now I can tell you what you spent on cooking last month, and you know, hey Jim, that's kind of interesting. Once, maybe the third or fourth time, I'm not so interested. The real use case in the future is to be able to say, you know, hey Jim, looks like you've left the house, looks like you've left the oven on, do you want to turn it off? So that real-time use case is where we're heading, and that technology stack is helping us get there. And then quickly to end with, that's not how my slide looked when I sent it through. It looked more like that. Ideas are cheap. You know, we've already talked about that. Data science, data engineering, data operations, that's how you extract the value. The issue is that these are very different disciplines. So data science is very creative, it's very research-based. Data engineering is far more about scalability, testability, robustness. And then we use different languages to do these different disciplines. We use different types of data sets, and you end up with this kind of divide between data science and data engineering. And I think the biggest thing you can do to try and extract value out of all of this data is to try and do that, to try and find a way to marry up your data scientists and your data engineers and get them working closer together. That means the faster you can do that, the more experiments that you can do, the more times you can fail, and ultimately the more times that you will succeed. So that's it. I've covered off Internet of Things, data and value. Hopefully there's been one or two interesting things in there. I'm around all day, so feel free to badger me for questions, or if you want to go into any more depth on anything there later. Thank you very much. Okay, a couple of questions.
Yeah, so about this all being connected and everything, I hopefully you're doing it securely and you're encrypting it. And how is the new government law, the one they're chatting about banning end-to-end encryption, how are you going to do about that then?
So I'm not a so the question was around security. How do you secure the data? So yeah, all of this stuff is encrypted. On the smart meter side, there's a massive amount of industry work that's gone on in terms of encrypting things. The signals in the home use its own standard of Zigbee, which is like massively more secure than the already secure Zigbee standards. So security is kind of built into the heart of it. The specific legislation about banning end-to-end encryption, I'm not an expert on security, so I can't comment on. I mean, I think one of the interesting things for all of us in terms of legislation, though, is the EU's legislation in 2017, where we all have to be much more upfront with our customers as to what we're going to do with the data. There's one over. Microphone's already gone that way, so I can catch me after. Sorry, there's just behind you.
You need to repeat the question. So as a natural follow-up, what about privacy? So in those days when a man came and take my reading, I didn't see it as much of personal data. Now that you can see when I'm cooking, I'm getting a bit more worried. So what are you doing about that?
Yeah, so the question was around privacy and the fact that collecting all of this data, it tells you when someone is cooking or when someone's doing something. I think this is a massive debate. So we've always been very used to, I think, going to if I go to your website, you collect data on what you sell me, and I think that's fair enough. I've come to you. In this case, maybe it's the other way around. I think on the metering side of things. Actually what's being metered is what's being sold. Yes, you can do stuff with that data. I think we've got a massive responsibility to do the right thing, because actually, the information that comes out of that. So if I can tell you, hey, your fridge is getting old, it's getting inefficient, it's going to save you money to replace your fridge. I think that's a really, really useful thing to do. Yes, of course, you could, all of us could do stuff with the data that we've got, and we just need to be responsible about that. But I agree with you. I think the Internet of Things will start a debate about what we do in people's homes. I think there's a very different thing about if I collect data from you in the street versus I collect data from inside of your home. And every single person playing in the connected home space and the Internet of Things space is going to have to think very seriously about that. Thank you.